Chapter 2. What is the name of Chapter 2? Means Unit 2. Unit 2, it is known as atomic structure. Then you know about some background informations of the atomic structure. In class 9, you know what are the fundamental particles of atom. Fundamental particles of atoms are proton, electron, and a neutron. So three fundamental particles are there in an atom. The picture to draw the three fundamental particles of an atom are known as the atomic structure. So in your portion include that atomic structure include discovery of electron, discovery of proton, and the neutron, like this. So these are included first. So first you study about all this structure, and the different scientists are given picture the structures of the atom. So first of all, study about the production of electron or discovery of electron. So first point, it is discovery of electron. Then electron was discovered by William Koch using a research experiment, and the research experiment at last moment it is finalized as a J.J. Thomson for the production of what? Production of electron. Then production of electron. So first research tube experiment you draw here. Production of cathode rays. So you see this U tube, it is known as the discharge tube. And what are the discharge tube? The two ends are connected at the two metal rod and inside the tube. So inside the tube, one is the two metal rods are there, one is the cathode and another is the anode. And these two cathode and anodes are connected by the high electric potential. That is the high voltage of electricity connected in it. And the tube, it is the pump out the vacuum, pump out the air present in this tube. And as soon as when all the gases are pumped out at a time, key is on so some rays or beam of light, it is coming cathode towards the anode. So in a discharge tube, so this is known as the cathode rays. So what is meant by cathode rays? So discharge tube experiment is drawn by the what? It is known as the Willem-Koch. Willem-Koch shows it is a discharge tube experiment, and finally, so electron is finally cathode rays is related to the electron of a fundamental particle of an atom. So discharge tube experiment was produced by Willem-Koch in the year 1879. So when a stream of ray of, you see here, this is the discharge tube, and discharge tube, it is the U tube containing two metal plates. So this metal plate, it is called the cathode, and another metal plate is called the anode. And this tube, all this air containing the tube, it is pumped out with the help of the suitable vacuum pump. And then key is on at that time some rays. So cathode starting from cathode towards the anode in the discharge tube. So all these rays are known as the what? It is known as the cathode rays. What you are written here, you see, when a stream of particles of rays, this is the stream of particles of rays, and coming from cathode towards the anode by applying high electric potential in a discharge tube. So this discharge tube, it is the high applying electric potential in it. So these rays cathode towards the anode we are called the cathode rays. And the cathode ray or cathode ray particles. So these rays travel in the straight line. So light travel in the straight line, how to realize here? When the pedal wheel is placed in front of these rays, when pedal wheel is placed in front of these rays, the image of the pedal wheel is found on the screen, and that shows that it is the rays travel in the straight line. And these rays were deflected both electric field and magnetic field, and these rays is attracted both electric field and magnetic field. So, and next point, these are deflected positive charge of electric field, and when you place near the positive charge of the electric field in it, so these rays is attract towards the positive charge of electric field. So this indicates that cathode rays containing a negative charge electron, and a negatively charged electron is related to the electron, a fundamental particle of an atom. So now you see the charge of the electron is equal to minus 1.602 into 10 power minus 19, and the mass of electron is equal to 9.1 into 10 power minus 31 kg. So this experiment, these two masses and the charges may be charges where this are produced by Millikan oil drop experiment and J.J. Thomson E/M experiment. So these two experiments are very long and better to study from your books. And here mentioned here, it is the charge of electron is how much and the mass of the electron is how much. So these are written in this case. And the next point, it is the production of proton or discovery of the proton. So proton was discovered by Goldstein in the year 1886. So what experiment? Experiment modified by the Willem-Koch experiment. Discharge tube is replaced by perforated cathode. What do you mean by perforated cathode? Means cathode means it is some small holes, metal containing the small holes are known as the perforated cathode. Perforated cathode is connected to the negative charge of the electric field, and the positive charge of electric field is connected to the anode. So when the two rays is emitted both sides, that means one is moved towards the anode, another is opposite towards the anode. So here you see the rays emitted, the stream of rays of particles emitted opposite towards the cathode rays are known as the anode rays. So what are the anode rays you see? Anode rays. The rays move opposite to cathode rays inside the discharge tube using the perforated cathode. When high electric potential is applied are called anode rays or Cannon rays or positive rays. What are the anode rays or Cannon rays or positive rays? The rays emitted, the rays coming opposite towards the cathode inside a discharge tube from perforated cathode by using perforated cathode are called the anode rays or Cannon rays or positive rays. And these rays is also same like the cathode ray. It is the travel in the straight line. How to realize the straight line? So when you place the pedal wheel or an object in front of these rays, the image of the object is found on the screen that shows that these rays travel in the straight line. And these rays are the material particles, and these rays are also deflected both electric and magnetic field, and these rays is attracted towards the negative charge of electric field. That shows that these rays consist as a positive charge particle. And positive charge particles according to the Goldstein. So the positive charge particles of the streaming of the rays in a perforated cathode inside the discharge tube is known as the proton. Proton is a fundamental particles of an atom, and it carries the charge of plus 1.602 into 10 power 19, and the mass of the proton is 1.676 into 10 to the power minus 27 kg. Yani osi adudi huzik yango nangi ngasai electron ga proton ga si kanana putho me haibadu khangtai adudi electron di discharge tube experiment ji kanana puthoi William Koch no putho me William Koch ki experiment ji use toraga J.J. Thomson na ngasai gi cathode ray ji putho cathode ray digi kari conclude to we hai tardi electron ama fundamental particle ni hai na putho eba adigi mazum electron ki charge kaya no electron ki mass kaya no loin shei da pira electron ki charge di minus 1.602 into 10 power minus 19 coulomb moira aduga ngasai ki mass of the electron di kaya no 9.1 into 10 power minus 31 kg moira adudi electron ki mass ka electron ki charge ga ani ji karamba experiment na puthoye na ngasai ki E by M ratio of the J.J. Thomson experiment and the Milkan oil drop experiment du ki matungina makhoi ki charge amasung magi mass e puthokpane ba gyantani ba aduga muk ngasai gi proton di kanana discover tawi proton di discover ja 1886 ta kanana E Goldstein tawi Goldstein karamba experiment season James Koch na puthomba ngasai cathode simply cathode season abai mautamana perforated cathode season nei adudi perforated cathode ai di karino metal plate amagi manung je oho ba masa leiba adugumba cathode to adugumba metal du boy koina perforated cathode kawi adudi cathode ray ma nang ngasai gi cathode oina loram madu da thok launa perforated cathode se samjan ma matamda ray ani khak pointing opposite towards the chat lewa adudi anode lom da chat pa ray du buna kari kaura cathode ray kaura aduga opposite towards the anode the satpadubuna kari kaura cathode ray kaura adudi the rays move opposite towards the anode inside the discharge tube when high electric potential is applied by using a perforated cathode are called kari kaure ikoina positive rays or cannon rays or anode rays kaweba khange ko adudi positive ray amasung anode ray amasung natragana cannon ray ji karino maju rays travel in the straight line chali haibagi kaino je praman kramain tawni haitardi rays na travel tawu matamda mai mamang da object se tamkanda object sigi image screen da tarba objects ki image screen da taba taragadi kari kauge bo light travel in the straight line ni haibji khangeba masi material particle ni masi gi rays hai aduga masi gi rays ju electric field amasung magnetic field da deflect tawi adudi horen electric charge plate ani khak thamjanba matam da rays hai ngasai gi negative charge rom da loin singjaleba aduna kari khangmang ami o ngasai gi anode rays hai kari doge bo ma je positive charge bu ba ray khara yaure haibji khangeba adai e Goldstein further study tawu matam da o this is the anode rays is related to the is the proton a fundamental particle of an atom ina man realize taweba adudegi di karitare charge of the proton je kaya no plus 1.602 into 10 power minus 19 coulombs ware adudi mass of the proton di kaya gamana re 1.676 into 10 to the power 27 kg oire haibji khangada ba sigyan tanani ko